All right, here's another example of graphing rational functions. So if you remember, our very first step should be to factor. So we have x squared, the numerator doesn't factor. And then in the denominator, I can factor out an x. So I have x times x minus 2. All right, so those are my factors. So now I find my domain and I say x cannot be equal to 0 or 2. X cannot be equal to 0 or 2. Can you simplify? Well, actually, yes, you can. You can cancel out an x so that you are left with f of x is equal to x over x minus 2, where, of course, x is not equal to 0 or 2. Okay, so that's our domain. So yes, you can. So if I can simplify, then that means there is a hole. So yes, there is a hole where at x equals 0. So continuing, we find our vertical asymptote by using our simplified function and setting that equal to 0. So our vertical asymptote is at x equals 2. X equals 2. So I set my denominator equal to 0, that's your vertical asymptote. Now to find the zeros, you would set the numerator equal to 0. So I set my numerator equal to 0 and I say, well, when x equals, if I set my numerator equal to 0, I find that x equals 0. So that is the point 0, 0. Okay? Now our y-intercept, you set x equal to 0. So not the numerator, but you set x equal to 0. So I end up with 0 over 0 minus 2. That's f of 0. And we get 0. So hey, notice our y-intercept and our zeros are all the same. Now, lastly, our horizontal asymptote. So we need to identify the degree of the numerator, degree of the denominator. Well, I have x to the first, x to the first. When the degree on the top and bottom is the same, we divide the leading coefficients. So I have 1 divided by 1, so I have the equation y equals 1. Okay, so that's the information that we need for this. So now we graph. Once again, I like to start with the asymptotes. So I have an asymptote at x equals 2, right? Yep, x equals 2. Okay, and I have a horizontal asymptote at y equals 1. So I get this graphed here. All right, so we've got the asymptotes, horizontal, vertical. Okay, now I'll go with the zeros here, and that's it. Okay, so remember, I'm going to have something that looks like this, or I'm going to have something that looks like this. All right, and so which one do I have? Well, I'm going to have the first option because of this 0. The 0 tells me where to go. Kind of missed it there. But this is about as precise as you need to be. It's showing me the general direction and showing me the general shape, although it's not terribly precise, and that's okay. All right, so I've got this. Now, last thing to check is holes. Okay, remember there was a hole. So where is the hole? The hole is at x equals 0. So even though my 0 and my intercept said that they were at 0, 0, I actually have a hole right there. And so the graph kind of looks like this. All right, so it shows me my domain that x is not equal to 2. I have an asymptote there. X is not equal to 0. There's an asymptote there. Okay, now my end behavior, as x approaches infinity, y approaches what? As x approaches negative infinity, y approaches what? Well, it's going to approach the horizontal asymptote. So as x gets infinitely large, y approaches your horizontal asymptote, which is 1. Same thing to the left side.